Step one, always going to be copy the givens exactly as they appear. First reason is a given. Okay, step two, I'd suggest you always look to interpret the given information. So if the given information was a statement, like R is the midpoint or something, some specific relationship that's embedded in a statement, interpret that statement. Right? If there's no statement, if it's just a relationship already or an equation, right, then you can move on to the next step, which is introduce the elements of your end state. Okay, so there's nothing to interpret here, so we can move to that step. Is TR introduced in our proof yet? No. So introduce it in the form that involves the pieces that were already introduced in the proof. So can we express TR in terms of TW, TZ, RW, and YZ? Yeah, TR, and I again would encourage you to introduce it usually it'll be introduced in this specific form. So even though TR is a part of a whole, introduce it as the individual part, not as a piece of the whole. So what is TR equal to in terms of the variables already introduced in the proof? It's a part of the whole thing, TW minus RW. Okay, so each of these elements was already introduced, so all we did is we were able to introduce the end state element in terms of what's already there. Okay? And anytime you're looking at the sum of the parts equals the whole, or the part is equal to the whole minus the other part, what justifies that? That's an example of segment addition. Okay? And we can introduce ty in the same way. Ty is also a part of a whole, so it's equal to the whole thing, in this case tz, minus the other part, yz. Okay? It's justified under the same reason, segment addition, so you can include that together in the same step. So those are both step two. Okay? Now you have an option here. Okay? There's two different ways to kind of get to the statement that tr and ty are equal. One possibility is you can take one of these equations from step two and you can transform it into a form that's identical to the other equation from that same step. And so that's the first method that I'm going to choose. So if we take this equation right here and write ty is equal to, what do we know we can replace tz with? What does our proof, early steps of our proof tell us tz is equivalent to? So we can replace tz with tw right here. And then what can we replace yz with? Its equivalent, rw. Okay, now, replacing means, or is justified just as substitution. Okay? So all we did is we replaced two values with their equivalents. And the reason that that's helpful is now we were able to identify tw minus rw, which is already a statement in step two. And so our final step here can now be to identify that two things, tr and ty, are equivalent to the same thing, tw minus rw. Therefore, two things equal to the same thing are equal to each other. Okay, so tr and ty are equal. We hit our end state. And the justification for two things equal to the same thing are equal to each other is transitive property. Okay, now, again, anytime you use transitive property, it's also described as substitution. So I'll put transitive property or substitution will work for that. All right, now, there's an alternate form of this proof that could have given us a different step 3 and 4. So let me talk through what that alternate form would be. Okay, so I showed you one possible way is to transform the equation in step 2 so that it's equal to the other equation in step 2. Well, the other way that you could approach this proof is you could take each of the expressions that tr and ty are equal to, and if you could say that tw minus rw is equal to tz minus yz, then you could substitute in those expressions to show that they're equal themselves. So that's the other way to do this, and the way that you would do that is, in this case, you'd start with the statement from step 1, which is tw is equal to tz. Okay, so if I take that statement by itself, and I want to manipulate it into this form, so I want to subtract an RW from one side. Well, if I subtract an RW from one side of an equation, to balance the equation, I need to subtract the same value or its equivalent from the other side. So what is equivalent to RW? YZ. So you can either subtract the same thing or equivalence, and that justification is subtraction property. Okay, and once you have that statement, you can now, if we take this relationship, TW minus RW is equivalent to TR, TZ minus YZ is equivalent to TY, so we can substitute that directly in. So here we can substitute in a TR, and here we can substitute in the equivalent TY. And so by substitution, we have our final statement.